Hello, so we are back at this time. We have a nice laptop to repair, huh? MacBook Pro. Hmm? Let's see the customer email. Now the job is coming from a computer shop. Now the email is on my language because the person dealing with customer service it's actually Romanian. I will translate for you. Hi Sorin, I have a MacBook which is not coming on. The customer doesn't know what happened, and we can't fix it. I will send it back today if it's okay. Just want to ask if you can tell me how much it will cost before you actually fixing. The customer is worried about how much it will be. Now, the customer asking for a price before repair. This is kind of impossible. I mean, in order to give you a price, that means I have to find a fault. If I found the fault, I found the faulty component. How can I know if I replace that component and the laptop it will work? I don't. So I have to replace that component and see if it's working. So, oh, okay, I replace it and it's working. Then the laptop is repaired. You know what I mean? You cannot give a price before repair. That's impossible. That's why I'm working with fixed price. So the MacBook motherboard repair is that price. If the customer agree, okay. If it doesn't agree, it's okay again. But I cannot give a price before repair apart from this fixed price. Now, look on the other side, yeah? Okay, let's say I'm identifying the component, yeah, running a diagnosis, I replace the component, the laptop is working, yeah? And the customer said, the customer, it will say, no, I'm sorry, it's too expensive, I don't want to fix it. Yeah, but I lost my time with the diagnostic, with the repair. So now the laptop is repaired, so I have to broken and send it back and actually take no money from it. So all what we can do is to check the motherboard, find the problem, replace whatever is faulty. Then I will send an email and I will tell them, you know what, this is the price. Because otherwise, how can I do it? No, usually I have a fixed price, but sometimes happen like a particular situation like this. Okay, we want to know, the customer want to know before. Okay, so the laptop is open. Looks untouched. I will say let's plug a charger and see what it's doing. So plug in the charger and the meter it is coming on. And we have 5 volts, 200 milliamps. Wait, 19 volts, 400 milliamps. 500, 600, 700. So actually the laptop is working. Huh? Pressing the power button, nothing happened. No, nothing happened. I mean, the current is the same. Liquid damage, I can't see liquid damage. Maybe you can spot liquid damage somewhere here. Well, I can't see it. Plug in the charger on the other USB. On the other USB, EA is doing the same. Lol. Okay, let's get the multimeter. Let's check the main power rail, which is 9.8. And it's going up because the battery is charging. Yeah. I will say let's wait a little bit and let's see what happens with the charging current. Actually, let's disconnect the battery and connect it again. What do you think about that? Just to be sure we don't have some weird SMC firmware issue. Okay, so the battery is disconnected. I will disconnect this cable also. Good. Let's reconnect back everything. Good. Perfect. Plug in the charger. and it's doing the same. And no picture on the screen, pressing the power button, nothing happened. That can be because the battery is low. Let's wait a little bit, yeah? So check here, 20 volts, 2 amps. That means everything is fine. Pressing the power button, and still nothing happened. Huh? Okay, I spent some time, probably like nearly 1 hour, quality time. This is a very complicated fault on this motherboard. So whatever I checked is good. Nothing shorted, nothing wrong, everything is fine. On the motherboard, what I found, you have this power supply, yeah? This power supply is a S0 power supply. That means this power supply is on only when the laptop is on. The problem is if you don't have this power supply working, the laptop will not come on. How did I got on this point? If I check the resistance, yeah, so check here. If I check the resistance to ground, actually I have, 1 second. I have like, no freaking way, 56 ohms. 56 ohms. It was like 3 ohms. But as soon as I came with the power supply, I seen the resistance change. It changed to 10 ohms, and yeah. Yeah, now it's 50. But you know how I got here? It was like 3 ohms, and I went online, and I found, 1 second, I found people claiming that power rail, that coil resistor should be higher. Where I found on the Bad Caps forum. Same motherboard, same model, and L8102, 43 ohms. Someone here said it's 18 ohms, but I had like 3 ohms. And, that made me wonder why. Now, this power supply, it's a 0.95 power supply, yeah? 0.95 volts. In order to find the fault, and nothing is shorted. No, even the MOSFETs are not shorted. No, probably are faulty. That's my thing. But in order to simulate a power supply, that's what we can do only with the power supply, with the lab power supply, and on that way we can simulate this S0 power supply like working. So what I'm gonna do, I have the power supply here. I have 0.9, hopefully 0.95. Anyway, close. 1 volt, 0.9, same thing. And that will come with the power supply exactly here. And if I come here, it's taking like 130 milliamps. Okay, in order to, it will not come on, obviously. In order to reboot or to restart or to start the sequence, the power on sequence again, I will unplug the charger. So it's taking 130 milliamps. Plug in the charger, 0.8, 0.7. So I have to take it and come back, and now it's taking 130 milliamps, and the laptop, the fans are spinning. Let's see if we are getting any picture. If not, I'll try it again. Unplug the charger. Back the voltage, plug in the charger. No, it's not working. I have to undo, and it's taking 80. 190, and the laptop start, check there, 300 milliamps. So I'm simulating that power supply as being working, and the laptop is working fine. Okay, obviously, in the moment I took the power out from that power supply, which obviously it's a CPU power supply, the laptop it'll go off. So I spent some time for this. Let me reset the laptop just to be sure, because it will hang on. Yeah, okay, 0. Um, let me speak with the customer, because this is not a regular fault. It's quite a complicated one. Let me see if the customer, with the computer shop, has to be with the customer and give them the price, and if everything is going fine, we're gonna go for further with this repair. Now, what I'm thinking is the problem actually either the chip or the MOSFETs. I really believe something is wrong, and I'm not speaking about shorted. Here is nothing shorted. I really think it's something wrong with these dual MOSFETs. But obviously, it can be something wrong with the chip. But the chip seems to be working. I mean, if I only simulate the power rail, everything seems to be fine with the chip. So give me some time, and let's see if the customer agree with this repair, and we're gonna see what is the problem. But what is to learn from here is faults hard to be diagnosed. Faults like, okay, if that power supply is not working, you will never gonna find it, because that power supply it will work only on the S0 state when the laptop is on actually. So the only way to figure it out is to simulate that power rail, then the laptop it will come on. And after it's coming on, obviously you can see there is no voltage and it's working with the power supply. So see you soon. Okay, so the customer agree with the repair. Now let's try to fix it. First, let's figure it out from the schematic. So we have this one, right? Now, how do I know it's non-shorted MOSFET? Is because if I will come, yeah, actually, I'm that's how we tested. We came with power supply exactly on this point, which is the middle of the MOSFET. Now, if the low side MOSFET it will be shorted, I will see that short on the power supply. If the high side MOSFET is shorted, then we will have our main power rail 12 volts here on the middle. So we know it's no shorted MOSFET here. But I'm assuming they are dodgy. But let's go under the microscope and try to check few things. Okay, so we are trying to repair this power supply. We have the coil, we have the dual MOSFET there. We have a capacitor and a resistor. C818151. 8151. 8152, 8151, yeah. So this is basically on the power input of the MOSFETs. And a resistor R 8146. 81 8146, 1 ohm resistor on the gate of the MOSFET. You know what? I want to check both resistors. Not sure where is this one, but let's check this one. So this one is 1 ohm resistor and it's good. We have 1.1 ohm. And the other resistor, I'm assuming, is here, this one. And this one is good. Both resistors are good. Tested with ground. Okay, that's weird. So this one is fine. Why we have 1 ohm on this resistor? 1 second. We have 1 ohm from here to ground. Why will have 1 ohm from here to ground? 1 ohm from here to ground. I mean, how can be 1 ohm from here to ground? Because the MOSFET is connected on the middle. So the only way this to have 1 ohm compared with the ground is if the chip is shorted on the output here on the U gate. Let me see. So this one is going here exactly to the chip, which is on the other side of the board. And the other end is going here. You know what? Let's come with some power here with the power supply. And let's see. I'm assuming the chip it will get hot because it's shorted, obviously. But let's check that. So power supply, and I will lower the current. Let me lower the current. Good. And that will come exactly here. I mean, it's not even important on which side. It's taking 120 milliamps. Now, 1 second, because we can find out. 1 second. Okay, so here we have 0 volts, and here we have 0.1. Check that. So we have 0.1 and we have 0. That means the short is on this side. And again, that side of the resistor, this one, this, 1 second, this one is going to the MOSFET. Wait a second. So one more time. This side of the resistor is 0 volts, and here is 0.1. Lol. How this gate can be shorted to ground here? Just tell me if anyone has an explanation, because clearly the short is inside of this dual MOSFET. So how this is possible? Because the MOSFET is not connected to ground. This MOSFET is not shorted. So how this gate can be connected to ground? This is crazy. I mean, this fault has absolutely no logic at all. Okay, so what is the solution? The solution is to remove this MOSFET and see if our short from the gate is going away. That's the solution. No, I'm not gonna take the board out. No. That's 1 hour more. So, when you fix this kind of MacBook, if you take the board out, put the board back, that's 1 hour more. And of course, who will gonna pay for that 1 hour more? The customer. Well, let's try to keep the price, kind of low. Perfect. So we are fine, right? Yeah, looks like. Good. Wait, let me disconnect the battery. I forgot about the battery. Now we have 480 degrees, about 60% air. And the MOSFET is out. Good, let's check now. So ground with my resistor, and it's not shorted anymore. Check here, it's not shorted. That's crazy. Yeah, the track is going here. So this one basically is shorted between this pin and this one. No, it's not. It's not shorted anymore. How this is possible? So this thing is not shorted anymore. So it was like that, so must be because this pin Yeah, it's going to the resistor. Yeah, from here to here, and it's not short anymore. So if I solder this thingy back, it will work 100%. So can be a short inside of the MOSFET, inside of the capsule, or I don't think it's a shorted track. No, that's quite impossible. Good, let's replace this one, just to be sure. And I'm gonna pick another one from here. Yeah, another MacBook board, which I have for spares. Perfect. Good, has to be like that. Perfect. I can't see, I have no light. Perfect. Nearly perfect. Yeah, now it's perfect. Come on. Perfect. Okay, so the chip is soldered on place. Chip, actually MOSFETs. Let's cool down the motherboard. Now the question is, that track is still shorted to ground? Let's see. So that track here is not shorted to ground, so we don't have a short to ground, which is perfect. And the coil has 23 ohms. Okay, let's see. Let's see. So we need to connect the battery back. Battery is connected. Pressing the power button. And nothing happens. So probably even the chip is dead. Actually, let's plug the charger. 1 second. Plug in the charger. We plug the charger, and all what we got is like 5 volts. We shorted the main power rail. How? Here is short. Here is short. 42 ohms on the main power rail. 1 second. Because the battery is connected, right? No, it's not working. What we did? One second. .9 ohms we plus. How? I mean, I'm pretty sure that chip is good. Let's see what we did wrong. I mean, I can't really see what we could do, did wrong. And it's making no sense. It's making sense only if this is some special kind of chip. There are some chips, but usually there are some chips which they are getting burned at low temperature. they can get shorted. We took out the MOSFET. One second. So we have plus, we ground, no. Plus, we output, no, it's not shorted. Then it's making no sense at all. Okay. You know what? Let me dip this chip in rosin and let's solder this chip one more time. I think it's my fault. I mean, not sure. Okay, perfect. Let's check one more time. Here is fine, and here is ground, and it's okay. Ground was this resistor and it's fine. Okay, this time everything is fine. Not sure what happened. Not sure. Let me cool down the board. What could happen? What about if that gate is actually floating because the chip is burned also? Yeah. That can explain what we've seen. We've seen the coil shorted with plus because the MOSFET had a floating gate. Possible. Let me plug the charger. And it's working. We have picture. That's crazy. Actually, it was a freaking bad soldering job, right? I can't believe. Yeah, you see, that's why it's important to use flux. Yeah, working fine. Yeah, we have picture. Let me put the battery back. I said, you know what? Let me not do like a mess because in order to keep something clean, the thing is to not make mess. Yeah, that's the first step. But yeah, proved to be a bad idea. And yeah, it's working fine. Yeah, we have picture working fine. I think the battery is fully charged. That's what I think. Or not. Wait, the battery is not working? Oh lol. How this cable came out? Yeah, this is the cable used for the battery to speak with the SMC chip. Because otherwise the battery it will not work. It is a good hardware. I will lie to say it's not a good hardware. Just look back a few seconds, yeah? Few minutes, sorry. We had, from some reason, I don't know, maybe it was soldered under the chip, we have a shorted coil to plus. Yeah, exactly what happened on the gaming laptops. And what happened? The input circuit got disconnected, the battery got disconnected. Yeah, it just, we can say a lot of bad things about Apple, but the hardware is just, it's beautiful. I mean, every power supply has a current sensor. Yeah, the board itself, like layers and tracks, is pretty bad compared with the other manufacturers. But otherwise, the design is quite good. Yeah, all good. Working on the battery, plugging the charger, charging fine. Yeah, 1.5 amps. The battery is like 70%. Perfect, we fixed it. I can't believe. Uh, the hard part was the diagnostic, and that's why I edited out because it was extremely boring. Yeah, 2 amps. It's charging fine. What voltage is supposed to be here? We can check that. Like how I told you, there should be 0.95, but we can check that. So on this coil, we have 0.95, you can see. Yeah. Let me shut down the laptop. So I shut down the laptop. And this power supply has 0 volts when the laptop is on S5 state or even S3. So that's why this kind of fault is very hard to be diagnosed. That's the only reason. And probably the only reason I figured it out to check with the power supply is because the coil resistance was different. And was different, I mean, okay, I was like, how can I know which is the good value? And I checked online on Google and I found people sharing same measurements from the coils. And yeah. So what's the resistance of the coil now? I'll tell you. So the resistance of the coil now is 33 ohms. I mean, for some reason, like last time was like 20 ohms, then was 50 ohms. I mean, you can't really count on this, but cannot be 3.5 ohms because I start from there from 3.5 ohms. So I'm gonna stop here. I will say thank you for watching. Like, subscribe if you like the video, and see you on the next one. Bye. Hey, if you find my content being helpful, don't forget you can support this channel by pressing the join button, and you can get instantly access to our members only cool collection and Discord private channels for support with your repairs. Also, you can have a look on our United Kingdom eBay, where you can find some cool and unique products, United States eBay store, or our Patreon page. Thank you.